Oh, add two numbers in a linked list. Okay, we are live. We are adding two numbers. This is a medium problem. 12,000 upvotes, 3,000 downvotes. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume the two numbers do not contain any leading zero, except the number 0 itself. Oh. Oh. Okay. Okay. Digits are stored in reverse order. So, for example, 2, 4, 3 plus 5, 6, 4 is 2 plus 5 is 7, 4 plus 6 is 0, 3 plus 4 is 8. You know, actually, this seems a lot easier than the other adding numbers we were doing. So the first thing I'm going to do is I'm going to copy paste the function over. And I gotta think here. I think it seems straightforward enough just doing addition. We'll grab our text, make our paintbrush blue because we're starting out, and we'll do 2, 4, 3, 5, 6, 7. So all we have to do is an out of bounds check, because we're starting with the least significant bit already. And I don't care which one's bigger. Let's make the small one bigger just to make it more confusing. Okay. So all we have to do is we have to do a for loop. Let's take a look at our assumptions first. The number of nodes in each linked list is in the range 1 to 100. We don't even have to deal with an empty list. And 0 is less than node value is less than 9. It's guaranteed that the list represents a number that does not have any leading zeros. This seems pretty straightforward. Okay. So what our algorithm has to do is we have to sum these. Which would be a 7. We make a new node. 7. So we do a sentinel node, a dummy node. Which will link to 7. And then we just instantiate new nodes as we go. And we'll do 2 pointers. Previous and current. Actually, what we can do, just to prevent all the edge conditions, is to do 2 sentinel nodes. I don't know if we need 2 sentinel nodes. I think we can start out on with the current pointing to the sum. We'll think about it. But basically what our Goldilocks case is going to be is we're going to then move over and then see if there is a carry, question mark. There might be or may or may not be a carry. And we'll do the linked list like this. Okay, cool. So we'll instantiate the variable. Oh, we need a ListNode class. Class ListNode takes constructor of type value of type integer and contains the pointer variable next integer null of type nullable is equal to null. And I believe that is what the list node is. Oh, I forgot to do this. It's a variable value of type int. We know the number of linked lists in each list is between 1 and 100, so we know that the first element is non-null. Okay. We will need a dummy node, dummy1, variable dummy2 of type ListNode. Zero, dummy2 of type dummy3. Do I want to call it dummy3 or dummy sum? Okay. We can call it dummy S. We'll call it 3. 3 pointers. Okay, then we're just going to group these together. Variable previous one equals dummy1. Variable previous 2 equals dummy2. Variable previous 3 equals dummy3. And then variable current 1 equals ListNode 1. Variable current 2 equals ListNode 2. Dummy1 1, dummy2 1, dummy3 1, dummy1 2, dummy2 2, and dummy3 2, dummy1, dummy2. Okay, so now we have our dummy nodes. Let's actually put previous on dummy1. We need to finish up our initial setup by saying dummy1 1 next equals dummy1 2 next. Do we have to do a non-null assertion? We literally just assign these. Dummy2 1, dummy3 1. Okay. Prev1 equals dummy1 1, dummy2 1, dummy3 1. Current 1 equals dummy1 2. Current 2 is dummy1 2 2. Okay. And then the next thing we do is we have to traverse through these nodes, and we have to do a null check on each of our top 2 pointers, pointer 1 and pointer 2. Current 1 and current 2 as they're called. So we'll do while current 1 next is non-null, or current, hold on, we can't do that. While current 1 is non-null, or current 2 is non-null, And then here we'll do our null checks. If current one equals null, if current one equals null, in this case where we're off the edge of anything. Oh, we also need a variable carry. We can't forget that. Let's put that at the top. It'll come in handy later. Variable carry equals false. If current one equals null, current one is equal to a new list node of value 0, and previous one next. We'll assert previous one is non-null equals current one. So here, if current one is null, current one now contains a list node of 0, and previous now links to current. And then likewise, we'll do the same with current 2. If current 2 is equal to null, current 2 equals a new list node of 0, and previous 2 asserted non-null next is equal to current 2. Okay. Cool. Now we filled in zeros if we need them. Now we'll do value of variable sum equals 0, which is going to temporarily hold the sum of the two numbers which we're adding. So if we're adding, say, 3 and 7 here, we're going to do sum plus equals current one assert non-null value and then add on current 2 value, and if carry sum gets one more, and carry equals false. So we consume carry. Now we check if sum is over 10, and then if we have to carry 1 to the next value over. If sum is greater than or equal to 10, we do a number of things. Carry is back equal to true. Sum minus equals decrement sum by 10. And at this point, we have to record the new value. So node value node of type ListNode is equal to ListNode sum. Variable current 3 equals dummy 2, 3. Okay, so current 1, current 2 are non-null. And then current 3 is now pointing to, and this is the part where I'm a little bit confused. I believe current 3 will now point to node. Previous equals current 3 . Previous 3 is going to equal current 3. Okay, so this pointer will move up. Current 3 will equal the node. And then previous 3 next will equal node. Okay. And then oh, okay. And then we have a broken initialization. Right now our dummies don't point to anything. Current 2 next, or current 1 next. Current 1 equals current 1 next. Previous moves up to current, and then current moves on to the next one. And the same with previous 2. Moves on to current 2, and current 2 equals current 2 next. We'll iterate through until both current1 and current2 are null. Looks like we have good traversal at this point. And then at the end, if carry value so at the very end, current1 and current2 will be equal to null. Value node equals ListNode initialized as 1, and are we okay saying current3? Okay, so 0 plus 3. If carry value node equals ListNode of 1, and then dummy3 1 next, dummy3 2 next. Previous 3 with current 3 equals the new node. Current 3 next equals node. Okay, that actually wasn't too bad. It took us just about half an hour to do. Let's go ahead and go through, since we still have time. We're not holding ourselves to that 15-minute standard just yet. Let's go through and do our addition. So carry's false. So here we have previous 1 and previous 2. And here we have current 1 and current 2. Okay. So going through, carry starts out as false. Dummy 1 1 is the list node of 0. D2 2 D2 to text d21 d31 d32. Okay, dummy11 is a list node of 0. Dummy21 also 0. Dummy31, dummy12, dummy22, and dummy32. Let us briefly drone our links for our initial setup. Okay. Dummy 3, 2. Okay. Previous one is assigned to dummy 1, 1. Previous 2 is dummy 2, 1. Previous 3 is dummy 3, 1. Okay, those look good. Here. Dummy 1, 1 next is stored as dummy 1, 2 next. Dummy 2, 1 next is dummy 3, 1 next. And dummy 3, 1 next is dummy 3, 2 next. Now, this is the part where we forgot. Dummy 1, 2 next equals L1, and dummy 2, 2 next is equal to L2. Okay. There we are. Now we're connected. Okay. And this is why we're walking through. We tried to sum current 1 and current 2. Let's increment current 1 and current 2 before getting any farther. So we'll have to do the first one outside of the while loop, outside of our Goldilocks condition. Okay, so we're going to do variable head equals L1 value plus L2 value and if head is a list node of init sum equals L1 value plus L2 value. If init sum is greater than or equal to 10, init sum minus equals 10 and carry equals true. And then value head equals ListNode value head of type ListNode is equal to ListNode init sum. And d3 dummy3 2 next equals head. So what we just did is we made this and we connected this. And then we walk everything by one. Current equals head. Current 3 equals head. Current 3 equals head. Previous 2 equals current. Oh, you know what? Okay. Okay. So we got carry equals false. Dummy1 equals list node. Got our list nodes. Next is 1 2 1 2. 2 1 goes to 2 2 and 3 1 goes to 3 2. dummy 1 1 next. Dummy 1 2 next links to L2. Dummy 2 2 next equals to L2. To our pointers, previous 1 equals 1 1, previous 2 equals 2 1, 3 1. And its sum. And then we do our first walk. Head equals ListNode of type init sum. Dummy 3 2 next equals head. Previous 3 equals previous 3 next. Current 3 equals current 3 next. Previous 1 equals previous 1 next, and previous 2. You know, I don't even think I needed to do all that. No. No, I screwed up the initial conditions. I'm going to comment this out in case I need it later. Because current 3 is pointing at dummy 2 3. Next and previous. I think that's good. Okay, awesome. It only took us 45 minutes. Whew, I gotta go faster. But this looks good. Let's run it. No pointer exception. That's no good. We're just gonna debug it. I'm gonna go to sleep. Oh, we screwed this up. Okay. Show a pointer. Run code. Pointer. Let's take our print line out. I need to print this line. Just a little bit of debugging, that's all. On our sample test cases. And I think we can submit. Ah, success. Okay, well, we eventually got to the success. We screwed up our initial pointers. We had the right idea, but I think it just got too complicated. I'm going to stop the stream right now, but I guess we got the medium problem done. I'll call that a win. Alright.